Hi, everyone. Can you hear me well in the back? Okay. My name is Natalie, and I'm here with Aditi. We're going to talk about our hard-learned GraphQL lessons because we were both developers working on GraphQL at Trulia for the first time with a lot of questions, and we couldn't find a lot of the answers to our questions online because it's relatively new. So we powered through a lot of our challenges, and now we're here to share our learnings. So, fun fact, I actually don't work at Trulia anymore as of a week ago. I work at Slack. But I was at Trulia for 3.5 years, and we were working on a team that focused on local information around properties that our users were going to come and check out. So if you are someone looking to buy or rent a home, you come to Trulia, but we show you all the information about a neighborhood, crime statistics, but we'll get into that a little bit later in this talk. Aditi, do you want to introduce yourself?
So, hi, I'm Aditi, and I work on the local team at Trulia. And what that means is I work on neighborhood information and information of the locality for properties. And my fact, not so fun, is I basically have been on a low-carb diet for about 2 years now, and I practice intermittent fasting, so it's impossible to ever get lunch with Natalie.
And I love making fresh pasta from scratch, which is very carby. It's super fun to make and then also really fun to eat it at the end, but unfortunately Aditi can't have a lot of my pasta. But anyway, so let's get into it. What is Trulia? For those who don't know, Trulia is a website you go to find out where you would like to live or what's on the market in terms of homes to buy, homes to rent. You can have a mortgage estimator as well, and a ton of data to see about properties on the MLS listings around. We specifically, like we said, work on the local team, and the local team set out to build a brand new page as of January of this year, and it was going to be a brand new page called the neighborhood page. Now, Zillow, oh, by the way, Zillow owns Trulia, if you didn't know. Zillow, Trulia, Realtor.com, Redfin, they all have property pages. So you see the listing, prices, all of the information related to the property, but they don't have neighborhood pages. And what we found was that 85% of our users think the neighborhood is as important, if not more important, than the home itself. So that was a huge opportunity for us to dive into neighborhoods and aggregate a lot of the data that we already had on other pages and kind of assemble it into one place. So here's what it looks like. Here is what the neighborhood page for Outer Richmond looks like. And if you're a San Francisco local, you'll see that the photo looks super nice and kind of sunny, whereas Outer Richmond tends to be foggy. But anyway, it's a beautiful photo. A lot of the Trulia photographers that we hired got photos of not only Outer Richmond, but many, many neighborhoods in the Bay Area and in Austin. And we're expanding to more cities like Denver and Boston and Austin, it rhymes. But anyway, so we have photos, we have some drone footage as well. So any drone fans in the audience, you can come to our neighborhood pages and see what it's like to see an aerial view of Austin and some neighborhoods in the Bay Area. And we also have a lot of quick facts to see about the inventory of what you can buy or rent in the area and price ranges. And we are in San Francisco, so you can buy something for $700,000 all the way up to $6 million in one little neighborhood. And we have a map with an outline of the neighborhood. Now, if we go down the page, we have the next section is called Explore the Area. This is where we show amenities that are powered by the Yelp API to tell you more about the restaurants, grocery stores, nightlife in the area, and plot them on the map so that you can see these denser blobs on the map relative to where you're looking to live and kind of figure out the space there. Because if you're moving cross-country from a city like New York to San Francisco, it's going to be hard to know what Outer Richmond is really like, so we're trying to make that easier for some of our users. So we have the amenities section here. If you scroll down, you can see some thumbnails of the businesses in the area. And then we have something called What Locals Say. Now, if you are moving from New York to San Francisco and you go visit Outer Richmond, you're going to know what the neighborhood is like based on what it looks like, but you might not be able to talk to a lot of locals and get a sense of what they think it's like to live in Outer Richmond. So we've asked those locals what it's like, and we say, does this neighborhood have sidewalks? Does it have grocery stores? Is it dog-friendly? So we've aggregated that data there. We also have full-text reviews that our reviewers submit to us and tell us what it's like, in their words, to live in Outer Richmond. A little bit lower on the page, we have the safety and crime section. So we plot all of the the crime incidents in the area on this map to help you understand where the prevalence of crime is in the city. And we also surface schools data on the page for families with kids who are looking to move to an area with great schools. Now, this is not a pitch for a Trulia neighborhood page, I promise. I'm explaining this because we're going to go into case study details in the lessons that we're going to share later on here, and we want you to know contextually where this fits on the page and how we learned what we did when we were working on GraphQL here. So a little bit about how it was built. We used React components, obviously, and we wrote many of them using TypeScript. I'm personally a TypeScript fangirl. We also used Next.js, which gives us a lot of tooling around server-side rendering and gives us a lot of helpful routing out of the box. We also used Apollo client and server, and GraphQL, obviously.
So let's go more into the GraphQL piece. You guys have already heard many times why GraphQL is so important. And we use it similarly to a lot of other companies. It's a gateway to all our microservices. All the clients now access the data using GraphQL. And the benefit it gives us is that we can put presentation logic into this layer. For example, if a user comes to Trulia and he doesn't have a profile image, we could check on the clients, each client, whether it was null, and then surface an avatar. But in this case, we can just set a default image in the GraphQL layer and send it back to each client. So that logic doesn't have to be replicated in Android, iOS, and web over and over. But how do we design this together? Well, we go for a domain-driven design. And I think most of you must have been present for the keynote yesterday when Jeff mentioned federated schemas. We're a big fan of that. So we have a mono repo with all our domains, and that's the data sources repo. And this way, experts can work on their piece without stepping on each other's toes. And also, our types are namespace with that domain, which sacrifices some reusability, but we've seen that it helps us move really fast. But then how does the source of truth come together? Because it has to be one big entire schema. So what we do is some schema stitching. In the GraphQL server, we take that other repo as an input, and we merge all the schemas for all the domains and make an executable schema out of it. And then the server exposes a GraphQL Playground endpoint, where you can come and look at the documentation. Developers can see how to make these actual queries and get some data back. Natalie's going to explain a little bit about how a domain data source looks like.
So we have this helpful flowchart here to kind of help you visualize how the setup looks at Trulia when it comes to GraphQL. So we have the client application that's sending a query via Apollo client to our GraphQL data source. And this is a isolated modular data source that relates to any one of our microservices that we have. So something like amenities has its own data source. Something like crime statistics has its own data source. So we have a data source. It has a resolver, a service, a connector, and the query propagates through these three components. And the connector in the data source is what eventually connects to the base connector in our server. And all this is doing is handling our get, put, post calls that are coming through and propagates them out to the external microservices that we have. And then once we get a response from those microservices, the response comes and propagates back all the way to the client. So this happens for each of our data sources. And what we have in our GraphQL server is a lot of the common stuff that we want to use. So the base connector is there, we have some logging functionality there, and some error handling happens there as well. So with that, we want to start sharing our first lesson. Now, I want to talk about how this came about first before I dive into really what the learning was. So when it came time to build the neighborhood page, what we did was us web developers sat down with the mobile developers. So we have our iOS and Android developers, some in the audience as well. And we started talking about, OK, we all need to build this neighborhood page. Let's decide on a common schema that works for all of us so that there's a single source of truth in the GraphQL layer, and we can move forward from there. So let's take an example like the schools section on the neighborhood page. We get some product specs, and they say that we want to display only 3 categories in the school section: elementary schools, middle schools, and high schools. So we decide, OK, we're going to show those 3 categories, but the response that comes back from our existing schools microservice also includes preschools as a possible field. So now comes the question, should we include preschools because maybe in the future product might want to add preschools, or do we leave it out for now? And based on a lot of the other talks in the conference so far, you might be able to predict what we did. We decided to trim out preschools within the GraphQL data source and only return the 3 categories that we need. Here's what's great about that. Let's assume we included preschools in the data source. Then our clients in 3 different places, in web, iOS, and Android, would have to add business logic to trim it out. That's terrible. So we would rather have one source of truth in the GraphQL data source, and as we know, it's a lot easier to add fields later than to remove fields if you add one preemptively. And with that comes a second example where we actually added fields we didn't need. So we have something called a reviewer. And like I mentioned on the neighborhood page, we have the what locals say section, and each of those users who wrote a review is called a reviewer. They have a name, they have a profile image, and the profile image is a URL to some specific size of their profile image that they've shared with us. So we have tiny, small, and medium as the possible options. Now, we decided this schema early on, so mobile apps decided to use tiny and medium because it was available as a field to use. But what they noticed is that when they were querying for tiny and medium photos, they weren't getting a value back because we actually didn't have a tiny or medium version of the photo to return. We only had the small version. So we were kind of in a pickle. We said, okay, what are our options here? We can't remove the field because they're already using it, so why don't we just backfill the value for those keys and actually just send them the URL for the small image instead, which is not ideal because if you're querying for a tiny or medium size and you get a small size back, it's kind of confusing. But that's one way to go. Second way to go is to deprecate the fields, but that's like a soft no, and you get this error message that says, use a small one instead. And with GraphQL, there isn't any versioning, which makes it kind of hard to address the certain situation. So anyway, this is like a learning lesson for all of you to consider that you should not include fields that you don't need, and make sure that you're returning values for the fields that you're agreeing to support. Otherwise, it might put you in a tough spot. All this to say, there's no need to future-proof your schemas.
So lesson number 2. Well, lesson 1 is a perfect segue into this because you shouldn't be mapping everything from your backend APIs to your GraphQL schemas, especially when it comes to your IDs. Why do I say that? Let me give you an example. So on this screen, you can see that we're requesting for amenities for a neighborhood. And you get different kinds, like restaurants, activities, and entertainment. On the right-hand side, you can see the type of an amenity. It has an ID, a name, and a category. Also, this goes back to when I said we namespace all our domains. This entire type is namespace with the amenities domain. So what happened? This looks good on first glance. We ran into a caching issue. Why? This is the raw GraphQL response, and you see a subset of the response, and you see there are 2 items. There's a Pizzeria Delfina, which is a restaurant, and if you haven't been, it's a great restaurant in San Francisco. And the second one is a coin-op game room, which is like Emporium, it's an arcade. And they both have the ID 1234 and type name amenity. So the reason why this is because in the backend, the IDs are unique only per category, and we map them straight over. But let's look at the way Apollo processes this. Apollo is really smart. So Apollo client tries to use the cache to get us data. So it goes to item of 0, looks in the cache for ID 1234 and type name amenity, finds nothing, finishes processing this, and puts it in the cache. Then it goes to the next item. It looks at ID 1234, type name amenity, finds it because it just put it in the cache, fetches that instead. So the Apollo query actually caches based on those 2 fields, which is ID and type name. And they need to be unique together. So the result we ended up getting was Pizzeria Delfina twice. Look at that. So this was a mistake we made on our end, and we fixed quickly by appending the category to the ID, and what this did was it made the ID unique again. So watch your IDs carefully. Another thing that you could have done would be to force fetch this query, but if you're not using the caching that Apollo gives to you for free, then maybe there's something wrong in the way you're requesting your data. So that's lesson number 2. Let's go to lesson number 3. This is also my favorite lesson. Because Natalie was mentioning earlier, our stack includes Next.js, that gives us isomorphic rendering. So you write your pages, and then they get rendered in the client and the server. Server-side rendering is awesome. Like, you can give the user something to look at so quickly. You have all these benefits from SEO. Awesome, right? Not always. So let's look at an example to understand why. So Natalie explained a reviewer earlier. This is the reviews query on the left-hand side. So we request for the text of a review from an API called the Reviews API, which takes about 60 milliseconds. And then we get the user ID associated with that text and make a different call to the user API, which takes double that amount. And with that call, we get the name and the profile image of the user. So more details about the user. And initially, on first page load on the server, we were using this query to render a markup. But we decided, this is taking too long. What can we do? Maybe we can remove reviewer information out and use it at a later time. So that's what we ended up doing. We decided not to SSR everything. We wrote a query to fetch the reviewer information at a later time, which is called the fetch reviewers query, turned the SSR to false over there, so it's only fired on the client, and rehydrated the page with that information. To give you an example of what that looks like, here you can see that when the page first loads, so the markup that's got from the client, all the reviews have Trulia user. And as soon as the client loads, it starts firing the query for fetch reviewers, rehydrates the page with the actual reviewer information. This helped to get some performance benefits. So you have to be intentional about your SSR and think carefully about what your server-side rendering. The next lesson is also about being intentional, but about nullability. So this is something that can trip you up, and you have to be very careful about it. To give you an example, we were looking at the neighborhood page before, and these are all the sections on that page. So the nice photos we saw, the amenities in the neighborhood, the reviews, the crime information, the schools. And initially, in our schema, all our arguments were nullable and all our fields were nullable. So we require a neighborhood ID to make this query, and that neighborhood ID is a nullable value. When the client passes it to us, the page looks something like this, which you already saw before. It's beautiful. We love it. But what happens when the client messes up? So in this case, the client actually passes a null value for the neighborhood ID. So what you're seeing on the left-hand side is just the footer and the header of Trulia.com, because those queries actually don't depend on the neighborhood query, so they loaded fine. But the rest of the page, I don't know if that's even useful at this point. If our neighborhood ID was a non-nullable value and we'd passed null to it, the page would have errored out. And honestly, I feel the error is more useful than the page you guys saw before. So being intentional when it comes to nullability is a great thing. Think about your error boundaries. Make sections that you think, fields that you think are needed to present the data as a bare minimum to the user, non-nullable. Make arguments that you think are needed for critically requesting data, non-nullable, and you'll be dandy.
Okay, to finish us off is our last lesson, 5. So what happened when we first started developing all of the code for the neighborhood pages, we were thinking about the code structure we wanted in our repo. We thought, okay, there are a lot of sections on this page that don't really relate to each other, so we can co-locate them as peers and in an isolated way to make each of them modular. So you have the amenities section on its own, the review section on its own, the crime section on its own. And I'm talking about this more in terms of React components. So when it came time for us to write our GraphQL queries, we thought, where do we want them to live? We thought at first we should co-locate the small queries that we had with the React components that we were building. So we would have the amenities query with the amenities React component together, and then there would be some higher order component at the root level that would build them all together. But we ran into some performance problems. What we saw was that the time to render was super long, and we didn't know why. So we did a lot of digging and figured out that it really depends on the way React Apollo works. So what we did was we joined all of them into one large query at the root level and executed it once on the server, got the data to hydrate all of the React components as the subcomponents, and it was a lot better. But let me go into a little bit more detail in terms of how the tree traversal works so that you may understand a bit more why the small queries ended up giving us terrible performance. So you have the root component at the top that's joining all of the components together. You have these subcomponents that live as children. And with React Apollo, you have the root component that has hopefully a query associated with it that's in charge of getting all the data that the subcomponents will need. But when you have small queries that are co-located with the React components individually in the child of the root component, these child components are simultaneously waiting, and they're waiting for the data from the root query to come down and hydrate before they render. But what you end up having is if you have a ton of small queries associated with the React components, you're waiting for each query to execute and resolve, and then it's going to take a long time in that resolve chain before it propagates up and then finally renders the whole DOM tree of React components. So that's something to consider. But you have some options here. So one option is to do like we did, one large query. But if you don't want to do that and you want to maintain the code structure that we initially set out to do, you can have the small queries there but set SSR to false, kind of similar to what Aditi was saying earlier. This basically turns off the execution of the queries on the server and waits to fire it on the client side so that your time to render is a lot quicker. And another option is to have the small queries co-located with the React components, but then export them up to the root and have the root query executed them all. But then you have to also make sure your performance doesn't take a hit if you decide to go that route. So final lesson is small modular queries may not be that performant, even if you want to keep your code organized. So that's something to make sure you look into when you're going to develop it.
So we're going to quickly recap all that we learned today, and we learned personally over the past year. So first one is, don't over-future-proof your schemas. So there are a lot of tools available right now to map your data tables or your backend APIs to GraphQL schema. Use them sparingly, try to understand what's happening, and don't over-future-proof them. And this especially applies to IDs. Make sure they're unique, or you might run into some caching issues like us. But the underlying thing is to understand what technologies you're using and how they're working, so you can make sure that your schema looks right. You don't have to SSR everything. That sounds counterintuitive sometimes, but whatever's on the top half of the page that the user is looking at, that's all you need to SSR, and everything else can be loaded onto the client. Be intentional when it comes to nullability. So think about your error boundaries and the data you really need to critically have a bare minimum page for the user. And a lot of qualifiers there, but that's the truth. Be intentional, make those things non-nullable. GraphQL gives us the ability to pick and choose the data that we request for, so use it wisely. And lastly, small modular queries may not be performant. In our case, they weren't. So it's good to know basically how everything's working. Again, this was a case where we didn't understand how the React Apollo DOM tree traversal was happening. So look at the technologies you're using and do what works best for you. That's all we have for today. But if you have any questions about pasta, intermittent fasting, GraphQL, feel free to tweet Natalie or I. Also, there are team members here today from Trulia. Come and talk to us about our stack and how we use GraphQL. Thank you.